As you know, I'm Kyneton the Genius, and today we are going to be continuing with day 5 on our Python in 10 days. If you come all the way to day 5, thumbs up to you. And today we are going to be starting with basic maths in Python. Don't be scared, maths in Python is really very easy. Now, if you are joining for the first time, hit the subscribe button below this video. That's a red subscribe button. Hit that subscribe button and activate notification by clicking on the bell icon, a bell icon below, beneath or beside the subscribe button. And if you're already a subscriber, that is great. You feel free to let me know how you feel about my lessons, and also feel free to like my video, share it around on your social network profile. Maybe we can help as many as possible to become Python programmers. So let's get right into the classroom and let's start working with maths in Python. Alright, so we are going to be taking this very interesting class today, and it's going to be the longest class of all. For all the days, this day 5 is going to be the longest, and it's also going to be the most interesting. I assure you that myself. The reason is because I've broken down the difficult part into very easy, small chunks that you can follow and understand. So the only thing you need to do, follow along as I do it. You're actually maybe going to be using the whiteboard behind me to also write, because I need you to understand this very clearly. Anybody that tells you that you don't need maths, the person is deceiving you. You need some maths in Python. We're also going to be using this board. You see this board here, I can also write on it. That is fine. So either way, we are going to be moving on, and I'm sure you are going to enjoy this class. Maths is not as easy, it's not as difficult as people think. Maths is really an interesting subject, and let's do it together. So the first thing I'm going to do here is meanwhile, we are going to be starting with day 5. I already created the project for day 5. To create a project, simply go to new project and then give it a name. So when you give it a name, so you just type a name there, the 5 or whatever, and you create a project. But I already created a project, so I'm going to be using it. I also have created a file in the project called math. Alright, so let me write a comment. As I told you, if you write a program, just put a comment indicating that you wrote this program. So I'm going to say program by Kyneton the Genius. So today we are going to be starting with a whiteboard section. So a whiteboard section, and we're going to start with the basics of mathematics, because in case the problem with math for many people is they don't start from the basics. If you start from some place that you needed some prerequisites, then you actually get lost and you find it difficult to make some progress. So the basics of mathematics is something called number system. The reason is because the number system is necessary because the way the humans use numbers is different from the way the computer uses numbers. The computer uses the binary number systems and sometimes the hexadecimal number system. Humans use the decimal number system. Sometimes the computer also uses the octal number system. Now, let's talk about the decimal number system. The number system is simply like a combination of different characters or different digits that make up the number system. For instance, if you are talking about the alphabet or the English alphabet is made up of 28 letters. The decimal number system is made up of 10 digits. So 10 digits like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is what makes up the decimal number system, meaning that anything you are going to be writing, any number will always take from this group of numbers, either take one of them or you combine it together to write whatever number you want to write. So there is no number like like something like this. There is nothing like that, or a number like this or whatever. So this is only what we have in the decimal number system. Alright, so then another number system. So in this case we have, this is the decimal, let me abbreviate it. We also have the binary, let me call it bin. It's only made up of 2 digits, 0 and 1. So whatever number you are going to be writing for the binary number system have to be only between 0 and 1. So a valid decimal number may be 29, or maybe 734, or maybe 200 or 201. Alright? So this is clear. A valid binary number will be 010, 111, 01, and so on. So a binary number cannot be 24. It's not a binary number. So the question now is, we must know a way to convert between decimal and binary, and between binary and decimal. So that's the first thing I would like us to do at the start of this program. But before we do this conversion, let me just I'll tell you about another number system that you need to know that computer uses sometimes. Sometimes you may see something like F7, 6A, 2D. This is a valid number, but this is a different number system. It's called hexadecimal number, made up of 16 different characters in the list. So here, for hexadecimal, which computer uses from time to time, we are not going to be talking about it in this class. We're going to be doing it a little later when I go deeper into mathematics. So the digits that make up the hexadecimal system is, you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. So this is the hexadecimal numbers, the hexadecimal characters that make up the hexadecimal numbers. So I could tell you that something like a number like 1A is a valid hexadecimal number. This 1A can actually be converted to binary, or can convert it to decimal. So now the question is, how do we convert? Let's focus on these two. Let's not make things complicated. Let's focus on binary and decimal, right? Let's focus on these two, right? So the first thing we want to do is how to convert from binary to decimal. Then we also see how to convert from decimal to binary, and also see how computers represent numbers. Before I continue, let's go to Python and let's display a binary number. So for instance, if I write A is equal to, let's say, 456, all right? This is a valid decimal number, not a binary number. And if I say B is equal to 100, now B can actually also be a decimal number, and can also be a binary number. Now the system understands it like a binary number. If you want it to be like a decimal number by default, Python represents the numbers like decimal numbers. If you want it to be a binary number, you are going to say B, or let's use C now, is equal to 0B 100. So this is now a binary number, right? So just have this in mind as we move along. So let's take, for instance, if I print C, let's run it to see what we are going to have. So it prints C, let's see. So it prints it to be 4. So it actually converts it to 100 is equal to 4 in decimal. We are going to come back to this. Let's do it the hard way on the board, and let's see how to convert this the hard way, and later we come back to Python. Now, if you look at binary numbers, you have something like, let's take for instance, we have 110. Okay, you can have 111, you can have 101, and so on. So all these are valid binary numbers. They're also called numbers to base 2, right? They are called base 2 numbers. So let me just show you a trick of how to convert binary numbers to decimal. So given a number in binary, how do you convert it to decimal? So let me start by writing something. We have 1, 2, 4, 8. Now you understand what I'm writing. Everything is 2 to the power. So we have, this is 2 to the power of 0. This is 2 to the power of 1. This is 2 to the power of 2. You see why it's called binary? It's only made up of 2 items. So that's why we only have 2. We have 16. We have 32. So what am I actually writing? We have 64. So let's try to convert these numbers we have here. We have a set of numbers. So to convert 101 to decimal, simply let's try to rule a line at this point and simply place them at this point. Let's say 1, 0, 1. All right, and then add up the places where you have 1. You simply add them up. And so in this case, you have under 4 we have 1. So we take 4. There is no 2 because we have 0 there, and there's 1. So this is going to give us what? 4 plus 1, which is 5. Alright, so that makes some sense. So let's try 1, 1, 1. That's going to give us 4 plus 2 plus 1, which is 7, right? 6 plus 1, 7. Even if we go for 1, 0, 1, 0, that is going to give us what? Under 8, we have 1. Under 2, we have 1. So it's going to be 8 plus 2, which is 10. Right? So this is a simple way to convert numbers from binary to decimal. But the problem is going to be when you are given maybe a number very long, 0, 1, 0, 1, 0, 1, 1, like this. So we can actually still do it by extending the numbers we are writing. Let's say we can write 128, continue writing, but at some point we'll run out of space. So we need a different way to be able to convert from binary to decimal. So it's still the same principle that we are going to follow, but in a different way. Let's take, for instance, this 101. This 101, let me write it from here. 101. We are saying that is equal to 4 plus 0 plus 1, right? All right, so we can also say is the same as 1 times 4 plus 0 times 0. Let's say 0 times 0. Okay, let me just write something else. Plus 0 times 2 plus 1 times 1. Now it's not very clear. Let me clarify. Let's make no mistake about it. So given a number 1, 0, 1, 0, it is in base what? In base 2. We are going to convert it to base 10 to decimal. So the first thing you want to do is to know how many items are there in the number. So in this case, we have 4 items. So it means we have, it's going to be 1 times 2 to the power of 3. So if you have 4 items, the highest power is 2 to the power of 3, right? So at this point, we have 2 to the power of 3, because if we take it, because we have 2 to the power of 3 here, if you write it here, it's starting from 2 to the power of 3. So we have 1, 0, 1, 0. So the first one is 2 to the power of 3. You understand? So plus 0, this 0 this time, because we have taken this, 0 times 2 to the power of 2, which is this one. It simply start decreasing the power, plus 1 times 2 to the power of what? This one at this point, 1 plus 0 times 2 to the power of 0. So this is how the conversion works. If you're able to break this down, you get the result easily. So the first step is to count how many items you have. In this case, in this very case here, you have 1, 2, 3, 4, 5, 6, 7, 8, 9. So it means you are going to start from 1 times 2 to the power of 8 and plus, take this second one, 0 times 2 to the power of 7 plus 1 times 2 to the power of 6. You continue downwards until you have 2 to the power of 0. So that is how it works to convert. Now, if we break down this, we have 8 plus 0 plus 1 plus 0. That is going to give us, so we have 8 plus 0 plus 1 plus 8. So 8 plus 0 plus 2, yeah, 2 plus 0, so it's going to give us 10, all right? So I hope this is quite clear. So I'm going to write out a few that you can use as assignments. So I'm going to write out this one for you. Do it by yourself. Write the answer in the comment below this video. And then we continue. So I'm going to just write out for you exercise. So convert to decimal. I'm not sure I get it right. So 1,1,0,1,1,1. So convert all these ones, they are in base 2. They are in base 2. So I'm going to just indicate that they are in base 2. They are all in base 2. Convert them to base 10 using the principle we already have here. Alright? Alright, so we are doing great. If you have challenges, let me know so that I can break it down a little more. So let's see how we can convert now from decimal to binary. So now we are talking about converting from decimal. Okay, so it means that you are given a number, let's say 200. How do you convert it to binary? So this is a bit tasking, but very easy as well. So what you are going to do is called successive division by 2. So you continue to divide this number by 2 and continue to take the remainder. So what we are saying is you write something like this. So the first thing is divide by 2. 200 divided by 2 is going to give us 100, right? And the remainder is going to be what? 0. Alright, divide again by 2, we have 50. The remainder is going to be 0. Divide again by 2, we have 25. The remainder is going to be 0. Alright? Divide again by 2, we have, now you have a remainder. So we have 12, remainder 1. Alright, the next thing is to divide again by 2. We have 6, remainder what? 0. And divide again by 2, we have 3, remainder 0. By 2, we have 3 divided by 2, we have 1, remainder 1. And divide again by 2, we have 0, remainder 1. Alright? So because we are dividing 1 by 2, so we don't have anything, the remainder is just 1. Okay? So after writing this, so you just accumulate everything together like this. I think it's upwards, so we have, going from downwards up, we have 1, 1, 0, 0, 1, 0, 0, 0. 1, 1, 0, 0, 1, 0, 0, 0, right? So hopefully I think it's correct. So this is 200 in base 2. So we can say 200 in base 10 is equal to 1, 1, 0, 0, 1, 0, 0, 0 base 2. Alright? So this is how to convert from binary, from decimal to binary. Let's just try a second one. Let's say we have 47 is in base 10, convert it to base 2. Right? So you do the same thing. You write it 47. Okay, so start doing the same. 2 divided by 47, we have, it's going to be 46 over 2, maybe 23. 23, remainder 1. 2 is going to give us 11, right? 11, remainder 1. 2 is going to give us 5, remainder 1. 2 is going to give us 2, remainder 1. Alright, so 2 is going to give us 0, remainder. So 2 divided by 2 is going to be 1, remainder 0, and 2 is 0, remainder 1. So if you put everything together from down up like this, so you have 1, 0, 1, 1, 1, 1 like this. So this is what we have, how to convert a number from binary to decimal. So let me take the call, please. All right, so I think by now we are done with three things: number systems, converting from binary to decimal, and converting from decimal to binary. Let me now give you a little assignment, because that is what I'm a teacher, so I normally give assignments. So I would like you to do this. Let's see. So your exercise to binary. So convert to binary. We have 49. So do this and leave the answer in the comment box below, and I'm gonna get back to you to see how good you did. So solve this and leave your results in the comment box below. I'm going to get back to you to see how much you did, and maybe give you some prize if necessary. Okay, so the next thing in my list is to go to Python and do exactly what we did now. All this conversion we did in a hard way, we are going to go to Python to do it the easy way. All right, so I'm going to go to Python at this point, and let's start with conversion from the first thing we did was from decimal to binary. So for instance, if we have a is equal to a decimal number 456, let's use something we already worked with. So let's use 247 as well. So a is equal to 200, and this is base 10, a decimal number. B is equal to 47. So to convert it to binary, simply say, let's say a underscore binary. Let's just give it a name. Is equal to binary a. It's as simple as it. Just say binary a, being a. So let's print out bin a to see what it is. So if we print it out, let's see. I'm going to just right click and say run. So it gave us what? So 0b 1100 1000. So if we go back to check, we have 1100 1000, as you can see. As you can see right here. So that is it. We got it perfectly well. So we can go for the next one, which is 47. So we have, I'm going to just say print being b, right? So that's in that case we are talking about 47. So simply to convert from this decimal to binary, simply use the being method available in Python. So just run it and we have the results. So 101111. So if we go back to check, we have it correctly. 101111 right here, as you can see. So you see, Python makes it very easy. So if you have problem with maths, for sure you overcome it with Python, because Python makes it easy and interesting. Let's now go for converting from binary to decimal. So let's say we have a number in binary. Let's just say we have, assuming that these numbers, instead of being decimal, they are binary. So we have 0b, we have 1010. So click all this. I have 0b, you have 11000011. So now there is no conversion needed. If you just print it out, it prints out automatically or implicitly Python converts it to decimal. So what I'm going to do, if I print A, Python automatically converts it to decimal. So you can use it to actually verify your results. In this case, 1010 is the same as 10. And B, let's see. So how this, the second one is equal to 51. All right. All right, so we are making progress. We are done with conversion. We are done with number systems in Python and in the whiteboard. All right, the next thing I want us to look at is something called arithmetic operators. In mathematics, you perform arithmetic, and in Python, we have operators we use to perform arithmetic operations. So I'm going to go to operators. Actually, we covered operators in day 3, maybe. What is this? Okay, so let's go down. So now we are talking about operators, and we are going to be talking about Python arithmetic. Let's start with, okay, so I want us to start with these 3. One of them is the modulus operator, the modulus operator, the exponent operator, and the floor division. These are the 3 things you need to know. It's explained here. I'm going to read out the explanation and we are going to do it. The modulus operator takes 2 operands and assigns the result to the left operand. Really? Let's see. Let's say we have A is equal to 10 and B is equal to 3. Print A mod B. Let's see what we have. So actually this explanation here is not right. The modulus operator returns the division when the remainder when a division is performed. Right? So the modulus operator returns the division when returns the remainder when a division is performed. Right? So in this case, 10 over 3 is 3 remainder 1. Right? That is fine. The same way, if we say 20 divided by 3, 20 divided by 3 normally is going to give us maybe 6.7 or something like that. So 20 divided by 3, just run it, is going to be maybe 6.667 or thereabout. But 20 divided by 3 gives us 6, remainder something, remainder 2. Because we have 18 is divisible by 3, then we have 2 is remaining. So if I print out 20 mod 3 or 20 modulus 3, it's going to return 2 because that is the remainder when 20 is divided by 3. So let's see what we have. So the remainder is going to give us 2. Alright, so another thing you will need to know is something called exponent. So exponent is something like, I'm going to just write it out a bit. Let me just go back to my chalkboard, my blackboard. I have 2 raised to the power of 4 or 3 raised to the power of 2. All these are called exponents. And you can actually have something like 16 raised to the power half. It's the same as square root of 16. Just have it in mind because this is maths we are doing. Any number raised to the power half is the square root of that number. So have it in mind. So we use exponent operator to do exponent. So in Python, let's just do exponent operation. It's represented with double asterisk. So in this case, if I say that C is equal to 4 raised to power 2, is going to be 4 star 2, 4 raised to power 2, and that is likely going to give us 16. So I'm going to print out C, and that will be 16, right? 4 to the power of 2, 4 star 2. Keep it in mind, and I'm going to just execute. As you can see, it gives us 16. Let's now try to the power of half. So you will have 4 print out 4 star 0.5. I've not tried this before, but let's see if it works. So it's supposed to give us square root of 4, which is 2. 2.0, so that is fine. All right. So the next thing I want us to get into is something called the bitwise operator. So bitwise operator is really very interesting. Now I'm going to open my chalkboard again on my whiteboard and let's work with bitwise operator. Now you need to pay very close attention because bitwise operation is very important in programming. In data structures and algorithms, you need a good understanding of bitwise operators. So let me kind of maximize this. I'm gonna, yeah. So let me see, I can just clean up my board a little. So bitwise operators is used to perform operations on bit by bit basis. So let's say we have A is equal to 1 and B is equal to 0. Now if we have A plus, sorry, not A plus B. So meanwhile the bitwise operators there are two of them. I think there are four of them. There is the ampersand, there is the, this is the and, this is the or, and this is the what's it called? The shift. Let's just scroll down a bit. The binary, the XOR, yeah. So the XOR is this caret, and we have the negation, this one, and we have the binary shift, which can be this or which can be this. Now let's understand what all this means. So when we say A and B, which is the first one, the binary AND, when we say A and B, it's going to give us, it's going to return the result to be 1 when the both operands are 1. So when both A and B are 1, it's going to return 1. So in this case, it's going to return 0 because any of them is 0 is going to be 0. Let me just put something. C is equal to 1 and B is equal to 0. So if we have A or B, is going to be 1. So for all means any of them that is 1, the result will automatically be 1. Alright? So we are going to apply it after now and then we continue. So we have exclusive OR. So if we have A XOR B is going to be, this is going to return 1 when both operands are different. So if we have A exclusive OR B is going to be 1, but A exclusive OR C is going to be 0 because A is 1, C is 1. So in this case, it's going to be 0. It's only going to be 1 when either of them is 1 and one of them is 0. So when two operands are different, exclusive OR returns 1. But once the two operands are the same, the exclusive OR returns a 0. Right, so we have this one is called binary complement, which is, you can say, negates, or if that's the name, I don't know, unary A is going to be equal to 0 because it's going to negate, it's going to convert it to, it's going to flip it to the other bit. So if you also say this, B is going to be 1. So this operator will simply invert whatever operand it has. So let's go to the next one, which is a bit dicey, and I'm going to explain it. So this one is called binary shift operator. So binary shift operator is simply going to shift the bits, right? So if you have something like 1 1 0 0, all right, and we are going to shift it. This one shifting to the right, okay. 1100 shifts by 2. What does it mean? It means that all the numbers is going to shift by 2. So let's just illustrate how it works. we have 1 1 0 0, and if we are doing a shift in this way, so this is going to shift here. So how we are going to have 0 will be left here because this will be this will be shifted. Now the first time it shifts, let's look at it 2 times because we are shifting by 2. So the first time is going to shift, this is going to shift this way. So it's going to be, the 2 ones will now be in this place. So we have 1 1. Okay, so we have 1 1, and we have 0 0. Right? So when you are shifting downwards, you'll be replacing what you shifted with 0. So it's going to be equal to 0 0 1 1. So you actually don't create new spaces at all. You don't create new spaces. So once it shifts downwards, the upper bit, because this is called the MSB, this is called the LSB. So this point and this point. So you are going to be replacing the MSB, the most significant bit, with 0 once you are shifting downwards to the right. The same thing happens when you are shifting to the left. When you are shifting to the left, let's say we have 1 1 0 0, and we are shifting it like this by 2. So in this case, we are going to shift how, I think it's gonna be, so when this one goes this way, and this one goes this way. So let's see, 0 0, because these 2 are going to replace the ones, and I think we'll have 1 1. I can't remember, but let's just try to see how it works. So we are doing a binary shift. So I'm going to print C is A is equal to 1 1 0 0, binary shift to the right of 2. And remember, it's going to be binary number. If I print A, print A being A. So let's see what we have. So it gives us 1 1. Okay, so yeah, so this is shift to binary shift to the right, and that is what we have right here. So we have 0 0 1 1. Let's see. We have 0 0 1 1, right? And guess what? You can actually do away with the first 2 zeros. They are meaningless, or they don't have any significance. So if you have 0 0 1 1, it's the same as 1 1. What now I want to make sure is when we shift to the right. So let me shift to the left, I mean. So shift to the left. So let's print out to see what we have. Okay, so when you are shifting to the left, you are increasing the significant bits. So you're actually adding more bits. So if we go back to our whiteboard, so if you have, when you are shifting this way, you have 1 1 0 0. You shift this one to this place, and you shift it again. You have and replace with 0. So 0 occupies these 2 places, and this one shifts to this place, right? Now 2 spaces are created at the least significant bit side. So those 2 spaces created, you simply fill it with 0. So have 0 0. So that is how the shift works. When you are shifting to the left, you are increasing the most significant bit, and you are adding 0 to the least significant bit position. But when you are shifting to the right, you are dropping some bits, right? So all right, so let's see what it means. Let's take, for instance, we are shifting let's go back to Python and let's see the effect of shifting on the numbers. So when we shift 1100 to the left by 2, it seems it means something. So let's call this A deck is equal to is equal to A deck is equal to 0B 1100. So the same thing. All right. So we are printing out A. Okay, we are printing out A, and we are printing out A deck. Let's call it A shifted. Let's call this A shifted. Okay. So A shifted is shifted in this way. Okay. So let's print out A deck, and let's see what the shifted value will be. So A deck, print it out by running the program. Is 12, right? It's 12. So if I print out the shifted value, print A shifted, let's see the value is going to be is 48. So what happened? So when we shift a number by 2, it seems we are successively multiplying it by, so in this case we are multiplying 12 plus 12 plus 12. We are multiplying by 3, by 4, right? So take a look. Just take a look. If we shift it by 1 space, we multiply by 2, right? So let me run it. So if we shift it by 1, we are multiplying it. It means we've multiplied the number by 2. When we shift it by 2, it means we multiplied by 4. So a left shift of a binary number multiplies the number by 2 times the number it is shifted with. So if we shift it by 3, it will mean we are multiplying by 8. So you multiply by 2, we multiply by 4, we multiply by 8, I think. So let's see, let me run it and let's see. So let's see, what we have, 12 times 8, is it going to give us 96? I think so. At this point, I'm going to start Jupyter Notebook and let's see what we have there as well. All right, so Jupyter Notebook opens up. So I'm going to simply say new and start a new Python file, new Python 3. So let's see, I wanted to say 12 times 8 to see what we have. Because we are saying that when you shift a binary number to the left towards the most significant bit, we are multiplying the number by 2 to the power of the shifted or the shift value, right? We are shifting a binary number to the left. You are adding new bits to the least significant bit side, and you are multiplying the binary the number by 2 to the power of what it is shifted with. So basically, I'm going to say 12 times 2 to the power of 3 times 8 to the power of 3 is 8. I'm going to run 96, right? That is fine. All right, so let's get back to Python to this place. And now we are shifting to the right. So let's go back to our chalkboard at this point. So we are shifting to the right. We are shifting to the right in this way to the least significant bit. We are losing some values. So if we have 1110, we are shifting to the right. So if we shift by 1 value, we have 0111, right? We shifted by 1. If we shift it by 1 again, we have 0 0 because 2 is going to move, and we have 1 1. So when it's shifting to the other side, which is to the right, we are losing those values. This value is going to drop. So consider the least significant bit at this point. Consider this place to be a cliff. So it drops completely. But once it's shifting to the left at this point, it stays, right? It stays, it doesn't drop, right? So let's just demonstrate what we are saying when you shift to the right. In this case, let's try to shift to the right, and shifting to the right results in division by 2 to the power of whatever it is shifted with. So let's shift to the right, if we shift to the right, okay, and that is fine, by 1. So print is going to be 6. Maybe it's going to give us 6 as a result. Yeah, so, and if we shift by 2, so let's see, I don't know what it's going to give us, but I think it's going to be 1, maybe. Let's just see. So it gives us 3. So we are dividing by 12 by 4. Yeah, 12 by 2 to the power of 2, which is 4. So take some time to get your head around it. And exactly, this is very interesting. I don't know if I explained this correctly, if I explain it the easiest way, but I think this is the best I can do. And take some time to go through the website to understand what is happening there. We are not done. Maths remains something we need to still get into. So we are not done. We are just, we've taken the first half. Let's now go to basic maths in Python. So basic math in Python, we are not going to be spending too much time, but we are going to learn a few things. One, we have different data types. We have the integer, which you already know. We have the long. Now, since Python is not a strongly data type language, how do you now specify the data type? When you write something like a is equal to, this is an integer. So what if you want it to be long? You can say a is equal to L. So this is L. Let me see. I think this has been deprecated, so I don't think it still works. Okay, so I don't think in Python 3, I think this doesn't work anymore. So you simply specify the long value. Long is like a larger integer with a larger size. Let's try something. 0x. Specify L at this point. It doesn't work. Okay, so right. So actually, we can do without this as well. Well, I can just take out this. So we are talking about integers here. I'm going to print a. Actually, using the 0x, I think it represents decimal number. Oh, okay. So now I don't want to create any confusion here. So if we use 0x, it represents a hexadecimal number. But that is not what we are saying. Let's take it out. Convert it to decimal. So 0x, let me just show you. And you write a, you can put in f anywhere. Okay? So this is a valid hexadecimal number. We have 0x in it. And we can use, remember we say hexadecimal numbers have 15 different digits, including A, B, C, D to F. So we can put in A, B, C, D to F, and it's a hexadecimal number. So 0x preceding the number means it's a hexadecimal number. 0b preceding a number means it's a binary number. So if we say A or B is equal to 0b, and we say this, it's going to be an error because binary numbers only require 0 and 1. So if we say 0b, it expects a binary number. Okay. Now floats are its numbers with decimal points, which you already know. So you can have these equal to 34 plus 0.09. That is fine. Complex numbers, we are not going to get into complex numbers at this time. It's not really necessary for you to move on with maths in Python. All right, so let's look at how to convert. To convert to an integer, you use int. To convert to long, you use long. To convert to float, you use float. So if we say, for instance, a is equal to 5.6, and I say print int a. So it's supposed to convert 5.6 to an integer and give us the result. So when you do something like this, it truncates it. It doesn't round it off. The int method or function truncates the number and gives you the whole number, right? Bin A converts to binaries. Now, if you say bin A, okay, so bin A, let's see. So we are trying to convert 5.6 to binary, and for sure you can convert a decimal number to binary. So we have mathematical function, we have absolute value. Actually, you don't have to worry so much about this. I simply recommend you try them out by yourself. Just what I would like to let you learn about is something about random numbers. The reason is because you may have to be able to learn how to generate a random sequence of numbers. So let me just go to Jupyter Notebook at this time, and let's see if we can generate random numbers. So I'm going to say A is equal to round range from 0 to 11, and at the end of the day I print A. So I'm generating a random number from 0 to 10 actually. So if I print A, round range is not defined. I think I need to import a module called random. So let me see, import random. I can't remember exactly, so I'm going to run at this time. So for some reason, round range is not there. So actually, the round range function is under random. So we are going to import random as rd. So I'm going to simply say rd dot round range. So it's going to be under random. So I'm going to run this and run this as well. So we have from 0 to 11. Okay, so actually the round range selects select a number randomly between a specified interval, right? So if you run it several times, it's going to simply be selecting a number. But what we want to do is to generate a sequence of numbers. So to generate a sequence of numbers, I think we have to use, just for learning purposes, if it's difficult for you, you can skip. So import numpy as np. So let's say np, you can say np dot arrange. So this is going to give us, I'm going to run this first. I'm going to run it. So this is now going to give us, okay, so it's going to display. And so you see it gives us a sequence of numbers. So actually to get a sequence of numbers you use a range. Yeah, so we call it a range, but it's actually a range function. So you can actually do the same thing in PyCharm as well. If I come back to PyCharm, I can say import numpy as np. So it says blah 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 install package numpy. Just agree to install it. That is fine. So numpy installed successfully. I'm going to just save file and save. Okay, it's already saved, I think. Save all. That's fine. So I'm going to simply say a is equal to np dot arrange and go from 1 to 11. So at this point I'm going to print a. So let's run it and see. So it gives us a list of values between the ranges we specify. Before I go, let me just teach you a little more, something called binary arithmetic. I don't know, I think I mentioned a bit of it, but let me just explain it a little more to you. So that is binary arithmetic. So let me just clean up this place a bit. So how do you perform arithmetic in binary? So you have, let's say, A. So let me just take a pen. Let's say you have, wow, what happened? A is equal to 1101 and B is equal to 0111. How do you do A plus B? Because it might give us 2, right? Right. So we need to find a way to fix this. So let's do binary arithmetic. Let me just explain to you what happens in case of binary arithmetic. Now, when you say 1 plus 1, it gives us 2, which actually is 1 carry 1, right? But that is not how it works. 1 plus 1 in binary gives us 10. If I'm not mistaken, let's see. 1 plus 1 is equal to 10. Actually, 1 plus 1 is equal to 10. The reason is because 1 plus 1 is equal to 2 in decimal, is equal to 10 in binary, right? So 1 plus 1 is going to actually be 0 carry 1, right? So it's going to be 0 carry 1. So 1 plus 0 is what? Is 1 plus 0 is 1 plus 1. That gives us what? 0 again, carry 1. Now 1 plus 1, it gives us 2 plus 1, 3. 3 is equal to 11. So we have 3 in decimal is equal to 11 in binary, right? Right, so you can just write out the key here. 1 is equal to 1, 2 is equal to 10, 3 is equal to 11. So with this key, you always know what your carry is going to be. So it's never going to be 4. So it can only be 1, 2, or 3. So 1 plus 1 we have 3, or 2 plus 1, 3, which is 11, which is 1 carry 1. So 1 plus 0 is what? Is 1 plus 1, and that will give us what? 10. So 1 plus 1 is 10. So we write it as 10. So this will be the result of the addition. So let me just write a few things so that you know. 1 plus 1 is equal to 2 is equal to 10. 1 plus 1 plus 1 is equal to 3 is equal to 11. So have this key in mind. Sorry, what am I doing? So have this key in mind while you try to solve binary arithmetic. Let me quickly do another addition and then I do another subtraction. Let me try to do something a bit tough. So let me say 1, 1, 0, 1, 1, 1. I have 1, 0, 1, 1, 1, 0. Let's try to add this and see what we have. Alright? So 1 plus 0 is 1. That is easy. 1 plus 1. I told you 1 plus 1 is 10. So I have 0 carry 1. 1 plus 1 is 10 plus 1. The one we carried, 11. So 1 carry 1. 0 plus 1 is 1 plus 1, which is 2, which is 10. We have 0 carry 1. This one gives us 1 plus 0 plus the one we carried, 2, which is 10. So we have 0 carry 1. 1 plus 1, 2 plus 1, 3, which is 11. So this is what we have. You can also do subtraction, right? So let's try to do a little subtraction. We have 1, 1, 0, 1, 1. We are subtracting 0, 1, 1, 1, 1. Let's say this case is it's a case of subtraction this time. So how do we subtract this from this? 1 minus 1, 0. That is easy. 1 minus 1, 0. 0 minus 1. 0 minus 1. It doesn't work. So take this one into this place. It gives us 10 minus 1, right? 10 minus 1 is 1 because 10 is 2. 10 minus 1 is 1. So what's left here is 0. 0 minus 1, it doesn't work. Take this one into this place. So we have what? We have 10 minus 1 is 1. So this is how it is. Am I too fast? You can pause the video and try to get your head around it. So this is basically like subtraction is like normal decimal arithmetic. So this is how to manage or how to handle in Python, how to do binary arithmetic. Sorry, let's just do for the last time, let's just try to sharpen our brain. This time, let's do some trig. Trig means trigonometry, working with triangle. Now, there is a man that is from Greece, I think he's a Greek philosopher called Pythagoras. And let's just talk about him a little bit. So Pythagoras came and said that after a whole lot of studies, he came and said that if you are given a triangle like this, I have that this is A, this is B, and this is C, right? So Pythagoras is telling us that there's a relationship between A, B, and C, provided that this angle here is 90 degrees. That's what Pythagoras is telling us. You see, so that comes to something like this. You have, he's telling us that the relationship is that A squared plus B squared is equal to C squared, right? So that means that to get C, you have C is equal to square root of A squared plus B squared. Now, let's not confuse ourselves. Let's not go too far and make things complicated. Let me just give you an exercise to do at home. It's going to be very easy. So I'm giving you this triangle at this point, and this rule work for base. So we have 3, and we have 5, and we have x. My question is find x, right? So there is another relationship I would just like to mention. Let's assume this triangle is not right angle triangle. So this triangle says A, B, C. And we have this angle to be C degrees, and this angle here to be B degrees, and this angle here to be A degrees. So what some mathematicians came up to tell us is that A over sine A is equal to B over sine B is equal to C over sine C. Alright? So let me just give you another exercise. This one is simple. Just apply this formula using 3 and 5 and find it. So let's see. In this case, let me draw another triangle. Let's say we have this triangle. It's not a right angle triangle. So we have this is 60 degrees. And this is, let's say, I have this is C. We don't know what C is. I'll have A. This A is 12. And we have this to be, let's say, another 60 degrees. Okay, so find C. So I'm giving you 2 assignments at this point. This is 1 and this is 2. So do these 2 assignments and leave the answer for me below. But before I go, let me just show you how to find sine. So sine is simply sin. So let's see. So if you have, let's say, A is equal to 60, right? So we can say, can just say print sine A. But now the sine function is under Numpy. I think it's under Numpy, so I'm going to say np dot sine A, or is it gonna be max dot? So let's see. I think you need to import max. Okay. Okay, so we have it's under max, right? But when you go to Jupyter Notebook at this point, I have A is equal to 60, and we can have sine A to be under np dot sine A. That is correct. So this is a bit confusing, but just use maths in this place in PyCharm. You can use maths the sine, And in Jupyter Notebook, you can also use master sign or use NP sign. Alright, so I would like to recommend you play around with every other thing. Try to read up what you have on the page. Try to see how it works. Read the explanation and try to use it, and it becomes clearer to you with time. Alright, I'd like to recommend don't run away from math, and also try not to give up. Try to do the best you can. I would like to say math is very interesting. I'll give you everything you need to get up to speed with math. For now, this is all the math you need for Python, and to move on with data science. When we are going to be starting with data science, there's other set of math that we may need. For instance, we talk about matrices. When we get to the bridge, we are going to cross it. So I'm going to stop here. If you've not subscribed, hit the subscribe button below. Leave me a comment if you have any challenges following this class. And I'd like to thank you for viewing, and we'll see you in the next day.